So just to get everything kind of tight, a coordinate plane is a plane, not an airplane. It's a plane divided into 4 regions used for graphing. And those regions are called quadrants. Notice the word quad has 4 in it, right? Quad 4. So here are the parts, and we're going to reference these parts. Let's start with the origin. Get it? Get it? Nobody gets it? Let's start with the origin. Like an origin story. The starting spot of stuff? That's okay, anyway. I thought it was funny. Let's start with the origin. The origin is the ordered pair. Oh, sorry, in class. Origin is the ordered pair 0, 0. And it's right there. It is right there. And by right there, what I mean is right where the x-axis and the y-axis intersect. So there's the y, there's the x. And we already talked about the x and y-axis. Remember that from doing reflections for our transformation unit? So we've got the origin of 0, 0. We've got the x and y-axis. Now, remember, what did I call these 4 corners? What did I call them? Quadrants. And we label them with Roman numerals. It starts in the upper right with quadrant 1 and works counterclockwise to get to quadrant 4. 1, 2, 3, and 4. 4 quadrants. And this is good because, like, people use this to communicate. I don't know if I ever said this before, but math is communication. And you're like, hey, I don't know where that point is. I'll be like, hey, look, it's right there, quadrant 3. Look in quadrant 3. Then we can all look at the same spot. And here's what we usually reference on the graph, a reference point. We reference ordered pairs. And an ordered pair is a point, x, y, on a graph. So an ordered pair is just a point on a graph. Now, does that point have any value in itself? Does it have any distance? Does it have... No, it's a spot. It's a reference spot, right? It's saying it's here. Now, you can get information from where it is depending on what your graph's about, or you can do stuff with multiple points. But it's just a reference spot. And again, we need that. We need to be like, it's right here. Guess what game you can't play without this? Battleship. Right? 2 coordinates, you line up the coordinates, you get a spot. That's an ordered pair. I think they should get rid of the letter-number combination in Battleship, put a coordinate plane, and help kids out in school. Right? Same thing. Why do you have to say like D5? Why don't they just be like 2, 4? Or whatever that be. Let's go about naming these ordered pairs. And I'm hoping this is like some serious review. If not, see me at Academic Help, all right? So A is located 3 left and 4 up, right? 3 left, 4 up. So that's ordered pair -3, 4. Remember, our ordered pair is always going to go x then y. And the reason you need that is x, y is different than y, x. We all need to be talking about the same thing. This is located in quadrant 2. All right, let's look at B. 2 right, 3 down. So 2, -3. Located in quadrant 4. C is 0 left or right and 2 up. 0, 2. And then that's not on a quadrant, right? It's kind of like between 1 and 2. You can just say y-axis. 0, 2 is right on that y-axis. D.
1 up.
3, 4, 5, 6, 7 right and 1 up. So 7, 1. Quadrant 1. E. 4 left, 6 down. That puts us in quadrant 3. And last but not least, G. I'm joking. F. And that is 5 right, left, 0, and that's located on the x-axis. You guys were playing Game Over Go for the start class. You have to know this stuff to play that game, right? So we should be going. Now, these are some new terms. I love it. I don't know. I get hyped when we get new stuff. We got discrete versus continuous, okay? So a discrete graph is a graph of distinct points. A graph of distinct points. So if you have like a little graph over here, you know, distinct points would be like what we had above. Just like these spots. This is discrete. You know, this spot, this spot, this spot, this spot. But like if you think to the decimals we warmed up with today with that turtle, was that distinct spots? No.
That was kind of
Connected, right? So a graph with connected lines and curves. All right, so kind of like that turtle on the beach, right? He's not teleporting around. You know, it's lines and curves that are all connected. That's continuous, which means everything, every little thing in between. So some other ways you could think about the difference between discrete and continuous is, don't write this down. I'm just going to write it here because it's a blank spot. Like the balance on your iTunes gift card would probably look something like this. Because would every penny in between everything be an option? You know, like chunks come off it, right? Like I don't know what a song costs because I have an Android, but like $1.29 or something on iTunes or something. So you're coming off in those increments, like in that whole chunk. It doesn't just trickle down to that, right? Or another difference maybe that I kind of use, it isn't perfect, but like filling a pool. If you put a hose in a pool and you're filling it up, is that continuous or discrete? Continuous, right? Like every little thing in between. Now, what happens if you were like taking a 5-gallon bucket and pouring a bucket in? That'd be more discrete, right? It's like a chunk in, a chunk, yeah. So that's how you can think of the differences between the two things, all right? Continuous versus discrete. All right, flip those notes over, friends. All right, friends, so looking at this, you're going to see these new words, domain and range. Domain is just all x values, and range is just all y values. All right, and I don't know exactly why, but organizationally in math, they put them in these brackets, which I'm trash at drawing, and I just keep trying to get better. So when I'm looking at these ordered pairs, my domain is going to be -3, -2, 1, 3. Notice I like to go organizationally least to greatest, and I don't have to list -3 again because it's already listed. So the word domain means all possible x values. -3 is a possible x value just in two different spots, right? You don't have to relist it. Cool? So the range is all possible y values. The lowest y value is -4, 0, 1, 2, 5. So again, domain is just all the possible x values. So I just pulled my x values from my ordered pairs. The range is all my possible y values. To list my ordered pairs in the table, I'm just going to write all my x, y ordered pairs. So -3, 1, -2, 0, 1, 2, 3, -4, and -3, 5. I think that's pretty simple. Again, the reason we have all of these is, I don't know if I ever said it before, but math is communication. And these are all just different ways to communicate and display our data. This is one of my favorites. It's called a mapping diagram. And you don't have to label the two sides. It's kind of universal. The left part is our domain, which would be -3, -2, 1, and 3. And the right side would be our range, which is -4, 0, 1, 2, 5. And here's how you make use of it. You draw arrows from each domain as it matches up to which range. So like -3 goes to 1. -2 goes to 0. 1 goes to 2. 3 goes to -4. And -3 goes to 5. If I were to do that again, maybe I'd just hand draw those arrows instead of use that tool. That's kind of jumbled up. But you take arrows and you just connect your domains to your ranges, and those are your ordered pairs as well. And lastly, graph, just like we just did. On our graph, we have points -3, 1, -2, 0, 1, 2, 3, -4, and -3, 5. Is this continuous or discrete? this is discrete, right? Just straight up points. All right, I'm going to do one more, and then y'all are going to do 3 on your own. Which, that's all we're going to have time for anyway. So, domain, all possible x values. I got -2, -1, 0, 2, 5. In brackets. The range, all possible y values. I've got -4, -3, -2, -1 and 4. Gotta let someone in, eh? Admit it. Gotta let them in. So, for my XY table, I'm just gonna put my points. Again, it's just ways to organize and display our data. For my mapping diagram, I've got the x values on the, or the domain on the left, x values, range on the right. And we'll draw arrows connecting what goes with what in my ordered pairs. And you'll see why some big value in these when we get to more domain and range and function stuff. And then we're to put all of our points. Continuous or discrete, friends? Discrete. So, for down here, I'm going to give you the XY table, and you'll fill everything else in. Cool. And that's going to be our intro. Our homework tonight's going to be on solving equations on Khan Academy review. So I know there's not like any time today in class for homework. You're doing review with equations, not on this new stuff, all right?